Good morning, Stat World. It's your favorite nerd, Mrs. Hamilton. Woo! All right. Today, we are getting into intervals. Again, you say? Yes, again. But this time, instead of proportions, it's going to be mu. So yes, today we will capture mu. Get it? I'm going to capture mu? Kinda? Oh, well. All right. Well, here we go. Hopefully you had a chance to print off the note sheet. If not, that's all right. Just follow along, relax, right? You are going to need, however, this T distribution chart. We've been using this bottom row so far, but starting today, we're going to be using all of the other values in here. All right, so get it ready, dig it out, have it ready on your phone, wherever, so you can go back and forth and look things up. All right, so confidence interval for amine. We are out to capture mu. All right, so holding the handle now is x bar. All right, we're not going to be doing proportions in this section. It's going to be x bar. We're going to use means. So means, standard deviations, average, those are the keywords you're going to see in these particular problems. The z interval for a population mean, it looks like these. We're trying to capture mu. We're going to use x bar as our sample, right? That's our point estimate. Plus or minus the margin of error. The margin of error is z star times the standard error. The standard error here is sigma, but we have to apply stats diet to it. All right, so this should look kind of familiar. We did this exact formula back in chapter 7 with sampling distributions. All right, so a little bit of vocab here to help you out. This is your point estimate. Point estimate, z star, that's your critical value. And then standard deviation divided by the square root n. This guy is called the standard error. Sometimes you'll see it abbreviated in textbooks with SE. All right. And then if you do the critical value times the standard error, that has a name too. That is called the margin of error. The mo. All right, so let's dive into a problem here so you can see what it's all about. IQ tests are normed. Hi, I'm normal. The mean is 100. The standard deviation is 15. A random sample, that's always good. We like random, A random sample of 100 students from a high school has a mean IQ score of 112 and a standard deviation of 16. Calculate a 95% confidence interval for IQ scores at this school. All right, so the first thing you want to do is define what it is you're out to capture, right? What are you going to capture in your net of truth? In my net of truth today is mu, which is going to be the true mean IQ score at this high school. I'll just abbreviate HS, right, at this high school. All right, so before I get into it, I need to make sure that my conditions haven't been violated. So I'm going to make a little section over here, conditions. All right, let's check those conditions. First condition, our data has to come from a random sampling, and it does, right? Random was stated in our problem. So for our condition check, we would say random is stated. For the next check, we need to make sure that our distribution is normal because z star, right? Z star is based off of that normal bell curve. Alrighty, so normal for means, it's not the Jake from Stat Farm. It's not that proportion where it has to be greater than or equal to 10. This time it's central limit theorem where your sample size is at least 30, or the problem could say it's normal, which is exactly what it did here. It said, hi, I'm normal. So normal is stated. All right, normal is stated. Number 3, independent. See, I'm not sure when they did their sampling of how many people was it, 100 students? I don't know if they did with replacement. What if they double dipped? So I need to do a quick little assumption check. It's that 10% condition. All right, we're going to assume at least 10 times 100, right? The sample size was 100. So we have to assume at least 1,000 students at this high school. All right, if it's a small high school, then that could be an issue. But if it's a school like North Cobb, then we're good. All right, so time to do our formula. All right, formula. We're going to capture the true mu using our x bar. Let's see. It said from this sample that we had a mean score of 112. There we go. Then we need the z star, and we're doing 95% confidence. So if you grab your chart, bottom row, z star, 95% is 1.96. Then we multiply it by the standard deviation. Here's where it might get a little confusing. This problem gives us two. They give us this sigma, and they give us the standard deviation of our sample, which would be an S. All right. The formula wants you to use the population standard deviation. So we're going to use 15 and not the 16. 16 is a distraction, I guess, in a way. All right, so we have 15. We're going to apply stats diet. So square root of 100. So there we go. We've substituted it into this formula right here. At this point, you don't have to type it in to do the clickety-click clicks. Instead, we can have our calculator run it all for us. If you head on over to, that's right, Stat World. Head on over to tests, and this is going to be test number 7. It's called a Z interval, and it's at the bottom of your notes right here, Z interval. All right. So once you're in there, it's going to ask for data or stats. If you have data, that means you've put your data in one of the lists. That's not what we have here. Instead, we already have the summary statistics. So make sure the word stat is blinking on your calculator. Then you can just put in the values from the paragraph. Our sigma was 15. Whoa, what happened, George? I don't know. Let's try that again. Our sigma is 15. The x bar, our sample, was a score of 112 at this high school. Hey, they're pretty smart. Our sample size was 100 students, and our confidence level is 0.95. Once it's all in, hit enter, and voila. Our interval goes from, all right, so our mu, our truth, is somewhere at 109.06 to 114.94. All right, bringing it all together, we've got our concluding statement. We are orange. We are 95% confident. The interval 109.06 to 114.94. And what does our interval do? It captures. All right, so we're 95% confident. The interval 109 to 114 captures the true mean IQ score at this high school. I love doing confidence interval problems because it's like a yummy little sandwich or a delicious little double stuffed Oreo. The top sentence right here is the same as your bottom sentence. So notice I'm repeating what I wrote here in my concluding piece. All right, so there it is. Let's try another one. Yes, T. All right, so finally you're gonna get to see what T interval is all about. In this problem that we just did, we knew the population standard deviation. But guess what? That's very, very hard to figure out. It's really hard to get an entire population and figure out all their data. So what do we have to use in the meantime? Samples, of course. So in reality, you usually do not have the population standard deviation. That's that sigma. So instead, we're going to use a sample standard deviation to estimate it. All right, standard deviation, and that's abbreviated S, and on your calculator, they put a little X right there. All right, so that's the sample standard deviation. Because we're using a sample, and it's not the true population value, you're gonna have many different curves, right? It's not a perfect Z curve anymore. So that's what this chart represents, all right? This represents all the different T curves. Whoa, I know, all right. So how do we know which t-curve to use? We use something called degrees of freedom. Degrees of freedom. And it's calculated sample size minus 1. All right, so it's adjusted slightly. Statisticians looked at many pieces of data, and they found that this is the best estimate. All right, so if we had a sample of 100 students, we would go to 100 minus 1, which is 99 degrees of freedom. On the chart, right, we would go to 99 degrees of freedom. Uh-oh, it's not there. All right, so notice 99 is skipped over. So you might just say, oh, go to 100. That's close to 99. Wrong! Don't do it! You actually went around all the way down to 80. All right, it's better to overdo it, right? They call that the conservative, larger, more conservative confidence interval. All right, so your formula looks very similar to what we just did on the other side. It's x bar plus or minus t star. And instead of using sigma, we're going to use the sample standard deviation and apply stats diet to it. All right. When we're using this formula, though, t star, since there's a lot of options in this chart, you also now have to list what your degrees of freedom are. So there's an added layer to the formula. All right, so take a look at this one. Questionnaires were sent to an SRS of 160 major U.S. hotel chain managers, and 114 responses were returned. So there's your sample right there. All right. The average reported time that the managers had spent with the current company, so the average was 11.78 years with a standard deviation of 3.2. Notice it's the sample standard deviation, right? They're telling me the data from their sample. We want the 99% confidence interval for the time spent at all U.S. hotel chains. All right, so first thing we got to do is define what it is we are after. So we're going to capture mu. What we're capturing is the true mean, and I'm just going to steal this sentence. Time spent by all U.S. hotel chain managers at a given company. All right. So then the next thing I gotta do is our conditions. And then we'll get into our formula, and then we'll have our concluding sentence. See how it's like a cute little sandwich? It's adorable. All right. Random was stated at the opening line. They had an SRS, so stated. All right. Next thing we got to check is normal. The problem didn't say anywhere that it was, hi, I'm normal, but that's all right because we had a sample size of at least 30. Our sample size was 114. So we can use the central limit theorem, right? So it's approximately normal then. I'll put by the central limit theorem, it's approximately normal. And then the third check is your independence. Alrighty, since they didn't say that they sampled with replacement, we're going to have to verify. We have to assume at least 10 times 114, so 114, slap a 0 on that. So 1,140 managers in population. All right. Time for our formula. Ooh, and we're about to get cut off. All right, when I use this program, I only get 15 minutes of recording time. So I'm going to go ahead and reset, and I'll finish this problem on part 2.